Assalamu alaikum students. Today we will cover the questions of the fourth chapter which we are currently covering from this paper of October number 2025, paper 2, variant 2. Question number 1. What happens to the volume of the fixed mass of a gas when the temperature is increased or the pressure is decreased? So if we remember from the literature, there is a direct relation between the temperature with that of the volume. So by increasing the temperature, the volume will increase. Whereas there is an inverse relation between pressure and volume. So if we have to, if they're saying if the pressure is decreased, so decrease in pressure will increase the volume. So from the given options, increased temperature will increase the volume, and the decrease in pressure will also increase the volume. So in this way, the correct option becomes the D option. Then question 2. The diagram shows the heating curve of a substance between which 2 points do the particles of the substance change from being in fixed positions to being mobile. So it means they are referring to the solid state here, because fixed positions is present in the solid state and the mobile phase is present both in the liquid as well as gas. However, we know that in this graph we cannot simply move straight from one state to the from solid to the gaseous state. It means they are referring to the liquid state, not the gas state. Here we have the horizontal lines indicating the plane lines, horizontal lines. They are representing the change in state. The change in state, or in other words, these are representing the phase change. We know that in the portion of P to Q is the solid state, and this increasing line which shows an increase in the kinetic energy, that now this portion represents the liquid state, and this U to T indicates a gas state. So converting from solid to liquid is during this portion QR. So from solid to liquid conversion is represented by QR region. So that's why the correct option becomes the B option. Then question number 3. A student investigates the diffusion of ammonia gas and hydrochloride gas. The two sets of apparatus are set up as shown at room temperature and pressure. We have these two set apparatuses, 1 and 2. The damp red litmus paper is present in apparatus 1 and the blue litmus paper in apparatus 2. The apparatus 1 shows color change in 30 seconds. We need to calculate the time for the change in color in second apparatus. So we see in the first apparatus, we have the ammonia gas, NH3. The MR value of ammonia is 17. Whereas in the second apparatus, there is HCl gas, and the MR value of HCl is equal to 36.5. So if the ammonia gas is taking about 30 seconds time to change the color, we need to calculate, or we need to expect the time recorded by the color change in the second apparatus. So definitely if the mass is higher, the hydrochloride gas will take much longer time to reach to the blue litmus paper, and converting this blue into the red color. So the time it will take will be longer, since the mass of HCl is higher than the mass of ammonia. So the only option with the higher time is 64 seconds. So this is the correct option. D is totally wrong because the HCl is an acid and it does convert blue litmus into the red. It converts blue to red. Fourth MCQ. Which row describes elements, compounds, and mixtures? So if we remember from the literature, elements is defined as the atoms of the same type bonded with each other. That could be of just one atom or could be of in the molecular form. The molecule will also contain, if the molecules or the elements are there, it will contain atoms of just one element. So according to this, both option A and B are correct. They are of the same atoms. The type of the atoms is same. C cannot be correct because it is not the definition of element. Element cannot be separated by chemical process, or it does not contain different atoms chemically joined. That's also incorrect. Then the column of compounds, it contains different atoms chemically joined together. So yes, the atoms of different elements combine with each other. Then it can be separated into new substances using chemical processes. So yes, if we have a large compound, it can be separated into different smaller compounds. So this is also a definition or explanation of the compound. Then C option is not correct because they do not have same type of the atoms. Both C and D are incorrect. Then the fourth column, can be separated, mixtures can be separated using physical processes. So yes, they can be separated by physical processes. So A and D are correct here. However, B contains different atoms chemically joined together. No, they are not chemically joined, they are physically joined together. Similarly, this is also wrong. So in this way, the correct option becomes the A option, having all the three ticks present. Then fifth MCQ, which statement about the atoms of ions is correct? So according to that, the mass number of an atom is equal to the number of nucleons and protons. So that is incorrect. It is basically the addition of neutrons and protons, not nucleons and protons. So A is incorrect. B says the electronic configuration of an aluminium Al3 plus is 283. So atomic number of aluminium is 13 and electronic configuration becomes 283. But for aluminium 3 plus, there shall be a loss of 3 electrons that should be removed from the third shell. So you must get aluminium plus 3 electronic configuration should only be 28. So that's why B is incorrect. C says that hydrogen is the only atom that has an incomplete first shell. So that seems to be the correct option because in the periodic table, there are just two elements in the first period. One is the hydrogen at the extreme left of the periodic table, and the other element is helium at the extreme right of the periodic table. So helium, as we know, contains 2 electrons and hydrogen contains 1 electron. So there is just one shell present in the first period and it is incomplete for the hydrogen. So it seems to be the correct option. And about the D option, it says most of the volume of an atom is taken up by the nucleus. So it is not the volume, it is rather mass. The mass of the whole of the atom is mostly taken up by the nucleus. So that's why D is incorrect. Then sixth question, which two values are used to calculate the relative atomic mass of a sample of boron? So we know if we have to calculate the AR of any element, we need an information. Let's suppose if I consider AR of the element X, then I will need the relative abundance of the isotope of one isotope of X, relative abundance of X, I would say 1, and multiplied uh, by its mass. So AR, or I would just say mass of the X1, mass of X1, and it is added into the relative atomic mass of another isotope of X. Let's suppose it is X2, that will be multiplied with the mass of the X2, and this continues until we have all the information of all the isotopes divided by 100. This is how we calculate the relative atomic mass of any element. So here we have value 1, say the total number of isotopes of boron. We do not require the total number over here. B says the relative abundance of each boron isotope in the sample. So yes, this is the relative abundance of every single isotope, relative abundance of X1, relative abundance of X2. So yes, we require these. So B and C are correct. Then value 2 says the total number of boron atoms. Again, no, we do not require the total number. We just require the relative mass of each boron isotope, which I indicated over here. Relative mass of all the isotopes. So from here we have the relative mass over here and relative mass over here. So in this way, correct option becomes the B option. Number 7, which statement which statement describes the structure of sodium chloride? Sodium chloride, it's an ionic compound. So we will be looking at the information related to the ionic compound or ionic bond. A says it is a lattice of alternating positive and negative ions. So yes, in the ionic compound we have the alternate cations and anions. B says it is a lattice of positive ions surrounded by a sea of delocalized electrons. It is the definition of the metallic lattice. So this is for metallic lattice. C says a mixture of sodium and chlorine atoms. No, they are not atoms, they are ions present. D says a regular lattice sodium and chlorine atoms. Again, wrong. And in fact, it is not a mixture, it is regular lattice. So there should be ions, not atoms. So that's why the only correct option is the first option, which is A. Number 8, graphite and diamond are both forms of the element carbon. Which row shows the number of other carbon atoms that each carbon atom is covalently bonded to in graphite and in diamond? So if you remember what we learned in the previous paper, that was a paper 2.1, we saw the structure of the diamond and graphite. So I can show you the diamond and graphite structure from the previous paper. This is paper 2.1, and here we saw the diagrams. This is the diagram of the graphite. This is diagram of diamond. So you can see that in diamond, every carbon is bonded with 4 more carbon atoms. If let's suppose this is the central carbon I'm selecting from here, and I'm selecting central carbon in the graphite over here. So you can see the total number of carbon atoms further bonded with the blue atom are 4. So 4 atoms in the diamond, and in case of the graphite there are 3 carbon atoms bonded directly with the blue carbon atom. So for this reason we will select the relevant option from here. In the graphite there are 3 and in diamond there are 4. So in this way correct option becomes the B option. Number 9, which row describes the structure and bonding in cobalt? So cobalt, we know it's a metal So we will look into the information related to the metallic lattice. All the metallic and ionic substances are considered to be the giant. They are giant structure, like ionic and metallic. And the diamond and graphite are also considered giant, but they are not metallic or ionic. They are rather covalent. Diamond and graphite, they comes along with the SiO2. They are all covalent and giant. Covalent is the bonding and giant is the structure. Be mindful about these words. So bonding present in the cobalt, since it is just a metal, mostly students are confused with the ionic, but as you remember, ionic compound would involve both metal and non-metal. Metal bonded with a non-metal will be considered to be ionic. If there is just metal mentioned in the question, you will say metallic. There is just metallic bond in it. So for this reason, C is the correct option. 10, 10 and other remaining questions, some of the other following questions are skipped because they are already covered. So we jump directly to question number 30. Which flow chart describes the correct treatment sequence of the domestic water supply? So for this purpose, you must be able to recall what we learned in the you should be able to revise the literature about the domestic water supply. So let's see the options. It says in option A, there is filtration, chlorination, then sedimentation. So chlorination, if you remember from the literature, it only came at the last of the process. It was the last step in the filtration. So chlorination is mentioned over here. This is chlorination step. Similarly, you can find the same last step mentioned over here. Chlorine added over here. So it cannot be the initial steps. It will always be the final step. So for this reason, A cannot be correct. In option D, we can find chlorination, which is present at the last. So it should be the correct one, but we can confirm it. It says sedimentation, filtration, then chlorination. So where is the sedimentation step? In B and D option, we have sedimentation, chlorination, then filtration. So this sequence is somewhat correct because sedimentation comes before chlorination, but the filtration step is basically in two different steps. If this is a sedimentation step, we have filtration just before it and after it. There are two different steps of filtration. One is before the sedimentation, and the other one is after it. But chlorination comes after the filtration. The same thing is mentioned over here. If this is a sedimentation step, like over here, we have the filtration, this one. This is the filtration, and this is sedimentation. They have not clearly indicated in this way, but you can see the explanation over here. Sedimentation step is the fourth step. Filtration is just before it and after it. So if we come back to the question, we can see that sedimentation is preceded by filtration. So that is the correct sequence. And after filtration is a chlorination, because chlorination is only the last step. So for this reason, D is the correct option. Then 31, which statement about oxides of nitrogen is correct? So for this purpose, you have to recall the literature of the catalytic converter. In the catalytic converter, we had these reactions present. The CO reacting with NO to make CO2 and N2, COs reacting with O2 to convert into CO2, NO2 is converted into N2 and O2, and the unburned hydrocarbons are converted into carbon dioxide and water. So these are the reactions in by the catalytic converters. So we come back to the question. Which statement about oxides of nitrogen is correct? They are made in the car engines by the incomplete combustion of gasoline at a high temperature. Although this statement seems to be correct because the oxide of nitrogen is being produced inside the car engine, but it is not because of the incomplete combustion of the gasoline. That is incorrect. That is not producing the nitrogen oxide. So that is incorrect. B says they are made in the car engine when nitrogen and gasoline react with oxygen in air at a high temperature. This statement also seems to be correct, that nitrogen is converted to oxide by high temperature. But the thing is that nitrogen in gasoline is wrong. Nitrogen is just not there in the gasoline, rather it is present in the air. Nitrogen is present in the air, not in the gasoline. So because of this wrong fact or logic makes it invalid. Then C says they are removed from the car exhaust by the catalytic converter and from nitrogen and sulfur dioxide. So no, sulfur dioxide is not produced. There is no formation of the toxic gas. No toxic gas should be produced in the catalytic converter. So that's why it is incorrect. D option says they are removed from the car exhaust when they react with carbon monoxide in catalytic converters. So this one is the correct option because we can see in this equation CO and NO, they are reacting together to make CO2 and N2. So this is the correct explanation. So that's why D is the correct answer. 32, from here comes the organic chemistry. The alkenes are homologous series. Which statement about the members homologous series of the alkenes is correct? So alkenes, as you know, they are those compounds which have the carbon-carbon double bond. The general formula is CnH2n. So they are carbon-carbon double bonds present. Now the homologous series are those which have the same functional group and there is a difference of CH2 between them. Any two members of the same functional group having a difference of CH2 are called homologous series. For example, I can say that CH3CH double bond CH2 is a propene, whereas CH2 CH double bond CH and then CH3, this is butene. Now you can simply see there is a difference of one carbon and two hydrogen atoms between them. So as a result of this, you can see they are of the same homologous series. Now look at the options. Option B says they have the same relative molecular mass. So no, two members do not have the same mass, they have different. Butene will have higher mass than propene. C say they have different chemical properties. No, they have same chemical property because they have the same functional group. D says they have different general formula. No, they have same general formula as I mentioned over here. So the only correct option becomes the A option, that shows they have the same functional group. 33, the diagram represents two processes X, Y, and their effect Z in the increasing global warming. This is a flow sheet of the increasing global warming, which row identifies X, Y, and Z. So the first block says emission of thermal energy from the earth. Now you must be able to revise from the diagram. This is a diagram of the global warming. Over here there is just one picture and then there is this second picture. The sun is putting radiation to the earth. Energy is radiated by the sun. Some of the energy is absorbed by the atmosphere of the earth. Some energy is radiated back into the space. So this is happening in this one picture, and then you can see over here sun is putting sunlight. Then some of the energy is absorbed over here in the surface, and then some energy is absorbed by the greenhouse gases in the atmosphere. So we go back to the question. It say, what is X? If the emission of the thermal energy is from the earth, then there will be the absorption of the thermal energy by the greenhouse gases. As you can see here, the absorption is there in this part, and the energy is absorbed by the greenhouse gases. So we can see option A is correct and option C is correct, because they are energy is being absorbed, not emitted. Emission is wrong, not emitted. Then Y says Y is just after X, emission of thermal energy to the earth. So when the energy is absorbed by the gases over here, if the gases are absorbing the energy over here, then definitely that energy can go to the earth and it can go to the space. Both are possibilities over here. So emission of thermal energy to the earth and emission of thermal energy to the space, all both combinations are possible from here. And then Z says, as a result of this absorption, the X was the absorption. What happens because of this absorption? This is Z. This Z is linking with the X because the X had a absorption of the energy. So because of this, there will be reduced thermal energy to the space. The global warming is only possible when the radiation to the space is lower down. This some energy which is labeled over here, if there is reduced energy loss to the space, that increases the temperature of the earth. As mentioned over here, uh, as the Earth's surface is warm, some of the heat rises and escapes into the space. The remaining heat is trapped into the atmosphere by greenhouse gases, further warming the planet. So we see that Z would be the reduced thermal energy lost to the space because they are being absorbed by the Earth's surface. And for this reason, A becomes the correct option. 34, which structures are structural isomers of each other? So in this case, we need to see the linking of the carbon atoms. You can see in option 1, there is a straight chain. In option 3, there is a branch. Carbon, in 3 carbon atoms straight chain, and then there is a branch on the central carbon. Now about the compound 2 and 4, we should look carefully. There is basically a linking in the straight chain form. You can see that all the carbon atoms are linked continuously. There is no intersection, there is no branching over here. So compound 2 and compound 4, they both are representing the same sequence. They are like this one, it is also a straight chain, and this one is also a straight chain. So they are not isomers. They are not isomers of each other. That's wrong. They are not isomers. So the only isomer, in other words, I can say that compound 1, compound 2, and compound 4, they are all same. They are all same compounds. So you can have just one isomer out of these three and another isomer from compound third, which is a branched compound. This one is a branched. So as a result of this, we have correct option to be C. C says 1 and 3 are the structural isomers of each other, 1 and 3. Then 35, the structure of an ester is shown. What is the name of this ester? So this is an ester compound, and we remember the part which is bonded with the oxygen through single covalent bond, that is coming from the alcohol part, that comes from the alcohol part, and this has only one carbon, so its name becomes methyl. So methyl is here, and the next part which is bonded with the carbonyl group, that comes from the carboxylic acid, and it has 3 carbon atoms, so the name is suggested to be propanoate. This is the one. So D option is the correct option. Then 36, which row shows the products obtained by the cracking of a large alkane? So we know in the large alkane, I will write a simplified form. A large alkane, when cracked, it converts into smaller alkane and alkenes combination, smaller alkane and alkenes combination. Along with, in some cases, there can be the formation of hydrogen gas. It is not necessary, but it can be there. But definitely there is no water. There is no water because you are not reacting with the O2. You are not reacting with the O2 to make water. You are not making carbon dioxide. You are doing this in the absence of the oxygen. The reaction is done in the absence of oxygen, so that's why you cannot have the water or carbon dioxide formed by the cracking. Both are not formed. So the only option with this is this column, B option, which has no water, and the other options are correct. There is alkene formed, there is hydrogen formed over here, but not the water. So the only option is the B option. Then 37, ethanol is produced by the fermentation of aqueous glucose or by the catalytic addition of steam to ethene, which row shows some advantages and disadvantages of these processes. So let's look at the advantages. The advantages of the fermentation, we remember it is not the fast reaction and renewable raw material is used, that is correct. Disadvantage of the glucose, slow reaction, that's possible, and the dilute aqueous ethanol formed, yes, because there is also the formation of the water along with it. And then in the ethene, the catalytic addition of ethene, advantage, the advantage of this is that it is a fast reaction and almost pure ethanol formed, that is also correct. All of these options are correct. Disadvantage, the renewable raw material, that's also correct, but RD is incorrect in the first part. Ethanol produced continuously, leave it. Slow reaction, it is not a slow reaction, it is a fast reaction. For C is incorrect. And D says non-renewable raw material is used, that is also correct. So we have 4 ticks produced in the D option. All of them are correct options. So this is the D option to be the correct one. Then 38, propanoic acid. Mind it, this is propanoic. It's not propanoic acid because the word En means double bond of carbon-carbon, carbon-carbon double bond. It is an organic compound that is both an alkene and a carboxylic acid. The structure of propanoic acid is given. You can see carbon-carbon double bond is present and there is carboxylic group. It means this compound has 2 functional groups at the same time. There are 2 functional groups. So we need to identify, or we need to check which polymer will be produced by the union of these monomers. This is a monomer, and what kind of polymer it will form. So carboxylic acid part is not a part of the main chain. It cannot be there in the main chain. This is the sequence of the main chain or backbone or skeleton. We have these different names: skeleton, main chain, or main chain or the straight chain. So it cannot be there because it is just the carbon which is there forming the main chain. So that's why this is incorrect. And similarly in A option it is incorrect. It cannot be the part of main chain. B and D seems to be somewhat similar, but there's a problem. In the actual monomer, we have just 3 carbon atoms present. There are just 3 carbon atoms. So in the option D, we have 4 carbon atoms. There is no CH3 present in this structure. There is no CH3 here. So B is the correct option because we have 3 carbon atoms, and this COOH is the side group. This is side group because if it is not the part of main chain, it is considered to be side group or side chain. You call it side chain or side group or substituent. There is also a word substituent. So COOH is basically the substituent. And we have remaining 2 carbon atoms, and this double bond is converted into the single bond. That helps you to connect the monomers with each other. So for this reason, B is the correct option. The question 39 and 40 are not to be done because that's not a part. So if you require my detailed notes of the whole IGCSE chemistry, you can let me know in the chat box, or you can reach me out on the WhatsApp number as mentioned over here on this watermark. So that's all for today, friends. We will cover the remaining papers in the next classes. Till our next class, take care and bye-bye.